Let's start our discussion about conic sections. Conic sections are the result of taking three-dimensional cones and slicing them at various angles to produce different two-dimensional figures. So these are the conic sections as they would appear in 3 dimensions. When I slide my plane in there, you can see that I have a circle, an ellipse, and a parabola, and a hyperbola in 2 dimensions. The parabola is the result of a quadratic equation. We've seen these before. We've dealt with them. We know that ax squared plus bx plus c is a quadratic equation in standard form. And we know that using the a term, the b term, and the c term, using those coefficients, then we can substitute their values into the quadratic formula, and that will give us our roots, what are basically our x-intercepts. Part outside of the radical, outside of the discriminant, here tells us the vertex. So the vertex, x at the vertex will be negative b over 2a, and when I substitute that value in to the original equation, I'll get y at the vertex. We can also use our skills in completing the square to derive the graphing form of a quadratic equation. And here, y is equal to some scalar, something I'm going to multiply by, times the quantity x minus h squared. And we'll talk about what h means in a little bit. This is a special value here. We'll talk about what that means in just a second. Plus some constant k. And again, this is another special value here that we'll have to see what it means in just a second. So let's take a look at an equation in the standard form. Using our quadratic formula, we remember that x at the vertex is negative b over 2a. In this case, the opposite of negative 4, which is 4 over 2, which gives us 2. Is that right? Another way to do that would be to use our knowledge of completing the square and set it in the graphing form so that we can get the vertex and then, of course, the roots. And here's how we do that. First of all, you all know that if I have two numbers that are equal to each other, if I add c to this a over here and I add c to this b over here, then I maintain my equivalence, right? That's not controversial. But you should also know that by adding c and subtracting c on the same side of the equation, I've basically done the same thing. I've added a net of 0, right? Because c minus c is 0. And so in doing that, I haven't changed my overall equation. And let's see how that applies to this equation here. I have y is equal to x squared minus 4x, and I'm going to put plus 9 over here. So I can take half of my b term here, which was a negative 4. That would be a negative 2, half of that, and then square it. I can add 4 to this side of the equation. But to maintain a 0 balance so I don't change my equation, I can also subtract 4. And that does the same effect as up here. I don't add or subtract anything from the equation. So now what I have is a perfect square trinomial here, if I were to group that using my associative properties, and then a number out here. So y is equal to this number factored is x minus 2 quantity squared, and then 9 minus 4 is a positive 5. And as you can see, this was the vertex I got using the quadratic formula, but as you can see here, I'm now in my graphing form. Let's move this back over. Here's my graphing form. And it says that I have a scalar, which in this case is a 1, right? We don't have a number out here, so my scalar is 1, times x minus h squared, there's that, plus my constant. So the vertex here is at negative h and k, or in this case, the opposite of this number here, which would be 2, and that number there, which would be 5. So that agrees with the vertex that we got earlier. So from here, should I want to sketch my graph, it would look a little bit something like so. Here's my y-axis, here's my x-axis. I would have my vertex at 2, 5, so there's 1, 2, 1, 2, 3, 4, 5, so my vertex would be here. And I can just use my x squared, so I'd go over 1 and up 1 for my first point on each side. And I would go over 2 and up 4, so 2, 1, 2, 3, 4 for my next point also on each side. And my parabola would pass through those points probably a little better than I can draw, but that's just a sketch. Notice that if I were to set this equal to 0, 0 is equal to x minus 2 squared plus 5, I would be solving for where, if at all, this graph would cross the x-axis, and as you can see, it doesn't. So what does that look like? Minus 2 quantity squared. I'd have to take the square root of both sides, and I would get the square root of negative 5 is equal to x minus 2, or plus or minus that. X is equal to 2 plus or minus the square root of 5i. So I have two complex roots, and I won't be able to cross the x-axis, and that bears fruit, right? You can see that my graph sketches upward. Based on my scalar of 1, I go 1 squared, which is 1, or 2 squared, which is 4. So this is 1 and 1. This is 2 and 4. That's how you sketch a graph using the graphing form